area of a surface of revolution. So we've done problems where we are finding the volume of an object, but now we're going to be finding the surface area of an object. And this is the formula that we're going to use is right here. So surface area is going to be equal to 2 pi times the function square root of 1 plus derivative of the function squared. It looks very familiar, by the way, because this is like arc length. So really just taking like the arc length, multiplying it by, if you remember, shells by 2 pi the function, and that's giving us the surface area of a revolution. So that's how this appears. And this is just different ways to write it right there. And then if you're going to find it going around the x-axis versus y-axis, they have these two formulas. All right, so when you rotate it around the y, you're going to use this one. Rotate around the x or perpendicular, use the top one. Okay. So just two examples here. Find the area of the surface that is generated by revolving the portion of the curve y equals x to the third between 0 and 1 about the x-axis. So what's going to be happening here is just show you between 0 and 1. This graph looks like this between 0 and 1. And what we're trying to do here is rotate it so that it forms this figure right here, and I'm just worried about just the surface area. So it's kind of like a horn. All right, we're just finding the surface area of this horn, essentially. So S is going to equal 0 to 1, 2 pi of y, which is x cubed, square root of 1 plus derivative of x cubed is 3x squared, squared dx. And we can do all this by hand. So this is going to give me S is equal to 2 pi, 0 to 1 of x cubed, square root of 1 plus 9x to the fourth. And what's really nice about this is it's going to be very convenient where we're allowed to use U sub on these problems. So let's go ahead and let U equal 1 plus 9x to the fourth. So du is going to equal 36x to the third dx. And then we're going to get 1 over 36. du equals x cubed dx. So x cubed dx is gone. So you can give me a 1 over 36. So I'm going to get 2 pi 1 over 36 root u du. Let's change the bounds then. So u of 0 is going to equal 1. If I plug in a 0, I'm going to get 1. And then u of 1, if I plug in a 1 right there, I'm going to get 1 plus 9, which is 10. So 1 to 10. So this will be pi over 18 out here. If I just play around with this a little bit. And rewrite that as u to the 1/2. So this is going to give me pi over 18 times antiderivative of u to the 1/2 is going to be 2/3 u to the 3/2 from 1 to 10. And then that's going to end up giving me, well, this 2/3 doesn't come out in front, so it's going to end up being pi over 27 times 10 to the 3/2 minus 1 to the 3/2. And that's actually, to find an exact answer, that's pretty good right there. I'll just rewrite this with the square roots. Make people happy. Same thing as 10 root 10 minus 1. And that's it. So that's the surface area of that figure right there. Okay. Do the same thing right here, but now we're going to do it around the y-axis. So we're going to find the area of the surface that is generated by revolving a portion of the curve y equals x cubed between x equals 1 and 2. It's not cubed, squared. So x squared between 1 and 2 looks like this. And we're going to take it and we're going to revolve it around the x-axis. So essentially, you're going to get this. Like a bowl. It's going to look just like a bowl. Okay, so that is ours. So we're going to find the surface area of this bowl. So here we go. S is equal to, well, first off, let's solve for x here. we're going to end up getting root y when we're solving for x. And again, I don't care that it's root y, not plus or minus whatsoever, because I'm only using the first quadrant version. So x is going to equal root y. So what is that between? That's between y equals, you plug in a 1 for x, you're going to get y equals 1. Plug in a 2 for x, you're going to get 4. Okay, so we're going to go from 1 to 4 of 2 pi root y, square root of 1 plus the derivative of root y, by the way. So dx over dy, a little different, not dy over dx, is going to be 1/2 y to the negative 1/2, right? Because that's y to the 1/2. So it's going to give me 1 over 2 root y squared dy. So it's going to give me, if I pull the 2 pi, 1 to 4 root y square root of 1 plus 1 over 4y dy. And then I'm just going to just pull this root y into there. It's going to make my integration go a little bit smoother. So it's going to give me root y plus 1/4. Okay, and then we can do a little bit of u sub here. So we're going to let u equal y plus 1/4. So du is equal to dy. So u at 1 is going to be 5/4. And then u at 4 is going to be 17/4. So this is equal to 2 pi of 5/4, 17/4, u to the 1/2 du. Yeah, I did this a little differently than I did. Oh well, this will still work out. I did this a little differently than my notes, but that's fine. So it's going to give me 2 pi. Antiderivative of that is going to end up being 2/3 u to the 3/2, 5/4, 17/4. So this is going to end up giving me 4/3 pi, and then 17 over 4, the 3/2 minus 5 over 4 to the 3/2. That's good right there. I'll clean it up just a little bit. So what we can do here is 4 to the 3/2, by the way, is going to be, so square root of 4 is 2, cubed is 8. So this is actually an 8. I can pull out an 8. So I'm going to get 4 over 3 pi times 1/8, which is going to give me 17 to the 3/2 minus 5 to the 3/2. Which is going to leave me with pi over 6 times 17 root 17 minus 5 root 5. And there you go. There is your area of your surface of revolution.